A person is standing on a weighing machine placed on the floor of an elevator. The elevator starts going up with some acceleration, moves with uniform velocity for a while, and finally decelerates to stop. The maximum and minimum weights recorded are 72 kg and 60 kg. Assuming that the magnitudes of the acceleration and the deceleration are same, find A, the true weight of the person, and B, the magnitude of the acceleration. And the G value is given to be 9.9 meter per second square. Okay, so what is given here is the maximum weight and the minimum weight recorded by the weighing balance, okay, weighing machine, and we have to find out the true weight of the person. Now this person is standing inside a elevator. Okay, so this is a elevator, and inside an elevator this person is standing like this. Okay, now we have to find out the real weight of this person, that is when the lift is not accelerating. Okay, so now this will first we will take the case of lift accelerating upwards, right? If the lift is accelerating upwards, so the net acceleration is upwards. So what we will have, draw the free body diagram of that person. If I draw the free body diagram of this person, it will look something like this. This is the point mass, okay, that is the person mass m, which is not known to us, and upward direction. See, now the person is standing on a weighing balance, right? This is a weighing balance, suppose, and on this the person is standing. That means the downward force due to gravity is mg, and the upward force is due to the surface. Okay, the surface is applying a force of n, that is the normal reaction, and as a result, since this surface is applying normal reaction on this person will also apply a force of same magnitude but in opposite direction. This is the normal reaction on the weighing balance, on the weighing machine, okay, on the weighing machine. So this n force is nothing but the normal reaction which is exerted by the person on the weighing machine, and that is nothing but the weight of the person, because n is equal to mg. Okay, so n happens to be equal to mg when the system is not accelerating. Okay, but now this will not be the case here. So here there will be a case which is different than this case. Okay, so here we will see how to do this particular problem. So I will draw the free body diagram again. Okay, so n is the weight that the weighing balance will measure. So n is upwards, okay, and mg is downwards. So normal reaction due to the weighing balance, this is the weighing balance, white color, and this normal reaction is upward on this person, and downwards gravitational force is there. Okay, now what to do? Okay, we know that the maximum weight, when it will happen, when the lift is accelerating upwards. If you don't know, we will see how did we find out that. Okay, since the acceleration net is upwards, we have n minus mg. So n is greater than mg, so because acceleration, net acceleration is upwards, so n minus mg is equal to ma. So the n is equal to mg plus ma. Since we saw that n is the weight actually measured by the weighing machine, so n is mg plus ma. Now we will see what happens when the net acceleration is downward. Okay, let me quickly draw the elevator over here. This is the elevator, and this is this person. Okay, let me draw the free body diagram again. Mg is downward, normal reaction is upward. So now net acceleration is downward. Net acceleration is downwards. So that means I have mg greater than n. So mg minus n is equal to ma. So mg minus n is in net force, and by Newton's second law, net force is ma. So mg minus n is equal to ma. From here I will get n is equal to mg minus ma. Now see, while accelerating downwards, the weight shown is mg minus ma, but while accelerating upwards, the weight shown is mg plus ma. So let's write this as n dash. Okay, so to distinguish from the previous case. So n dash is mg minus ma. So both these values are given. Okay, the weights recorded are 72 and 60 kg. Okay, so 72 kg means 720 Newton. Sorry, 72 into 9.8 Newton, and 60 kg means 60 into 9.8 Newton. So n will be equal to m times g plus a. Okay, and n dash is equal to m times g minus a. So what is n? N is equal to n is given to be 72 kg. So 72 into 9.9. Since the g value is 9.9, mass we don't know. This is 9.9 plus a. Okay. Now while decelerations and accelerations magnitude are same, so here again I will do this. N dash is 62, right? Or 60, yes, 60. 60 into 9.9 is equal to m times it is equal to m times 9.9 plus a. Okay, so this will be, so from here what we can do is find out, since there are two variables in this and this is minus a. Okay, there are two variables and two equations, so by solving this simultaneously we will get the answer. So let's take the ratio of these two. What we will get, we will see. So ratio, if I take of this 1 and 2 equation, what I will get, 72 into 9.9 divided by 60 into 9.9 is equal to, m and m will cancel, which is 9.9 plus a divided by 9.9 minus a. So this and this will get cancelled, and this is 12 into 6 is 72 and 12 into 5 is 60. So this is 6 by 5. 6 by 5, and here this will be, if I, okay, let it be like this. Okay, 9.9 plus a divided by 9.9 minus a. So now this becomes 6 times 9.9 minus a is equal to 5 times 9.9 plus a. So this will be 6 into 9.9 minus 6a is equal to 5 into 9.9 plus 5a. Okay, so this 6a will go here, then it will become 11a. So this 11a is towards right, and towards left what it is, 6 into 9.9 minus 5 into 9.9. Okay, so now let me adjust the screen here. Okay, so now this is 1 into 9.9, because 6 into 9.9 minus 5 into 9.9 is simply 9.9, because 6 minus 5 is 1. So this becomes 9.9 divided by 11 is a. So now 11 into 9 is 99. So this is 0.9 meter per second square. So the acceleration we got is 0.9 meter per second square. But now what we have to find out? We have to find out the mass, because mass is needed to find out its true weight. Okay, the magnitude of acceleration we found out. So now the mass will be how much? So use this equation, 72 into 9.9, 72 into 9.9 is equal to m times 9.9 plus a. M times 9.9 plus a. So a is 0.9. So what we will get here, 9.9 plus 0.9. This is equal to m times, if I add 9 to this, 9 into 2 is 18, and this is 10.8. 10.8, 9.9 divided by 72 into 9.9. Okay, now we will get 72 into 9.9 divided by 10.8. So this will be equal to m. Okay. So now how we will do this? We will again take multiply by 10 on numerator and denominator both. Okay. 72 into 99, 108. So we have to find out what is the weight, right? So instead of doing this, what we can do is that we will multiply both the sides by 9.9. So what will happen? We will directly find out the weight. Okay. So this is our weight. Okay. So we have to find out this. So this is 72 into 99 into 9.9 divided by 108. So this will be, we can divide it by 12. Nine. So this is 3 into 2, this is 3 into 3, this is 33. So this will be 66 into 9.9. So this will be 66 into 9.9 Newton, but the weight shown will be 66 kg. Okay. So the mass will be 66 kg. So weight is 66 into 9.9 Newton, but the mass that it will finally calculate is 66 kg. So the 66 kg is the actual mass of the person.